Okay, welcome back. Lesson 15, Intro to Fractions. Whole numbers, which we've been working with thus far, are used to count whole things. To refer to a part of the whole, fractions are used. So a fraction is a number of the form a over b. A little bit about that. If a is less than b, we say that's a proper fraction. So just a little bit of vocabulary here. If a is greater than or equal to b, we say it's an improper fraction. And we're going to work with those a lot in a moment. So, we'll talk about the parts of a fraction. A is called the numerator, b is called the denominator. Now I'm aware that most of you are, comfortable with the basics of fractions. Where people run into trouble is, add, subtract, multiply, and divide fractions, and then order of operations on fractions without a calculator. But we're going to build through the levels here together. So first we want to start off with visualizing fractions. One way to visualize fractions is to picture them as shaded parts of a whole figure. So for example here, we've shaded in one part, and I'll put a blue dot, but there's 1, 2, 3, 4 parts altogether. So one part shaded out of 4 equal parts. So we say that this is representing 1/4 of the whole, read as 1/4. Let's try again. 1, 2, 3, 4, 5 are shaded, 5 parts shaded. So we call this out of 6 total parts. So I always think part to whole, or the ratio of part to whole or part to total. Part to total parts, I kind of like to think about it like that. So we would read this as 5/6 is shaded. Now this is kind of an interesting one. 1, 2, 3, 4, 5, 6, 7. 7 shaded parts. But how many equal parts are there? So 1, 2, 3. There's 3 equal parts. So this would be a visualization of 7/3, but think about this. I like to think about it like this. 7/3 really means 2 1/3. So that will probably make more sense to you. So we've got one big block shaded, we've got another big block shaded, and then we've got 1/3 of, this big block here shaded. So we have 2 1/3. So most people think in mixed numbers, and that's okay, more so than they do in improper fractions. So if you're looking at this saying, hey, that's 2 1/3, you're right. It's just that 2 1/3 means the same thing as 7/3. And if you forgot how to do that, we're going to talk about that in a moment. Okay, types of fractions, like we said a moment ago. Proper fraction is when your numerator is less than your denominator. So 1 is less than 2, 3 is less than 4, 2 is less than 5. These are all proper fractions. An improper fraction has a numerator that's greater than or equal to its denominator. So 8's bigger than 3, 5 is equal to 5, and 4 is bigger than 1. So these are examples of improper fractions. And mixed number, you see, is basically a sum of a whole number and a proper fraction. So 2 plus 2/3 can be written as 2 2/3, and 3 plus 1/5 can be written as 3 1/5. So we call that a mixed number. Another way to visualize fractions is to graph them on a number line. Okay, so I'm going to make my own number line here. If I had to graph this by hand, I'd put 0 here and 1 here, and then I'd chop the number line into fifths. 1/5, 2/5, 3/5, 4/5, and 1 means the same thing as 5/5, right? So think about that. 1/5, 2/5, 3/5, 4/5, and then you know exactly where that lives. 3/5 is right here. So we can add to this diagram here 1/5, 2/5, 3/5, 4/5, and then 5/5 means the same thing as 1. So that's why we're landing here at 3/5. 1, 2, 3/5. Okay? So you do want to think about where these proper fractions reside. So all your proper fractions reside, assuming they're not negative, reside between 0 and 1. I do want to say that your improper fractions can be converted into a number greater than or equal to 1. So would live, above 1 on the number line. Okay, other things to bear in mind. Fraction properties of 1. Anything divided by itself is 1. And here's an example. 5 divided by 5 is 1. So you can read that fraction bar as division. You can say 5 over 5, or you could say 5/5, or you could say 5 divided by 5. Likewise here, anything divided by 1 is itself. So 3 divided by 1 is itself, which is 3. Those are just little reminders. And fraction properties of 0. 0 on top, so 0 divided by something is 0. I like to think about it if I have no money and I divide it among my 3 friends, they each get nothing. 0 divided by 5 is 0. But the other way around is undefined. Something divided by 0, that's impossible. So 3 divided by 0 is undefined. So one of my students said 0 under the line is undefined. It's how she remembered it, sort of singing a song. 0 under the line is undefined. That's true. You just want to store that into your own mind. 0 in the numerator, we can perform that division and get 0, but 0 in the denominator we cannot, and we call it undefined. And it's good to try that on a calculator. If you hit 0 divided by 5, it's going to spit out 0. But if you hit 3 divided by 0, it's going to say error, or possibly undefined. Writing mixed numbers as improper fractions. That's why I say you may be rusty on this. So we're going through our basic skills before we do anything, involving algebra. So 2 3/4, you remember that you multiply the 2 with the 4 and then add on the 3. So you're taking, 2 times 4, which is 8, plus 3, which is 11. Let's try another one. 14 2/5. Convert, note to self, convert to improper, to an improper fraction. Well, now we know the trick, and I'm going to highlight it. 14 times 5 is something, and if you have to go off on the side and do your multiplication, that's okay. Is 70, and then 70 plus 2, if you're making a mental map, so that's 72 over 5. So again, 72/5 is mathematically equivalent to 14 2/5. So definitely practice. Let's do another one of those. Just practice, rinse and repeat. Converting from mixed, so 2 1/7. If I convert that from a mixed number to an improper fraction. 7 times 2 makes 14, plus 1 makes 15, so 15 over 7. And voila, that's not too bad. And now, of course, we need to practice going the other way. If I throw you the improper fraction, can you send me back to mixed? Yes, you can. So divide the denominator into the numerator and look for the remainder. Basically put your remainder over your original denominator and write a mixed number. So let's try that. Okay, so 7 into 18. 7 goes into 18 about 2 times, right? 2 times 7 is a 14. Draw the line and subtract. And your remainder, throw your remainder over your divisor, which is 7. Aha, so 2 4/7. 2 4/7. That's it. And then you're right if you reverse the flow, and say 7 times 2 makes 14 plus 4 makes 18, which is the original numerator. Let's try again. Let's divide 4 into 152. 4 goes into 15, 3. And then 4 goes into 32, 8. And hey, there's nothing remaining. So that's okay. Sometimes, an improper fraction could turn out to be a whole number when you perform the division. Let's try again. That's why I have a special case on that. Now let's try 3 into 85. 3 goes into 8 twice. 3 goes into 25 about, 8 times? And look for the remainder. Remainder 1. Throw your remainder over your divisor. Aha! So 28 1/3. Sorry, my handwriting's a little crazy there, the pen. So 28 1/3. So really just practice that mechanism of taking your improper fraction, dividing your numerator into your denominator, and looking for the remainder. And notice where the remainder goes. All right, hope that helps. We have not started operating add, subtract, multiply, and divide fractions yet. That's coming. We're going to build the levels. So this is Intro to Fractions, Lesson 15. Good luck out there. Look for future videos on the operations and how to reduce a fraction, and all that will be coming soon.